First, we will be talking about resonance. Sometimes it is possible for a molecule to have more than one valid Lewis structure. Here we are going to use the nitrate molecule, and I've already drawn all three valid Lewis structures. But the actual Lewis structure is an average of all of these, and I use arrows to indicate that there is resonance. And the actual NO bond will have a 1 1/3 covalent bond instead of the one shown here. We have localized versus delocalized electrons. So, the localized electron model assumes a molecule is composed of atoms that are bound together by sharing pairs of electrons using the atomic orbitals of the bound atoms. So pretty much what it's saying is the localized electrons don't really move at all, and it's pretty much your bonds and lone pairs. But in reality, we have delocalized electrons, and this means that the electrons move as they wish and as needed in the specific molecule. Here we are going to use formal charge to figure out which Lewis structure is most likely in a specific molecule. So we are going to use the formal charge formula. Formal charge equals the number of valence electrons in the atom minus the total number of non-bonding electrons minus the total number of bonding electrons divided by 2. And we also have to keep in mind that molecules try to achieve as low as a formal charge as possible, and negative formal charges should be on electronegative elements. Alright, so now we are going to use the formal charge formula to figure out which of these three Lewis structures is the most likely for the OCS molecule. And now we're going to start with O, which has 6 valence electrons, and you can use the periodic table to figure this one out, minus the number of non-bonding electrons, and that's just 1, 2, 3, 4, minus the amount of bonding electrons, that's 1, 2, 3, 4, divided by 2, and you're going to get 0. And for carbon, it has 4 valence electrons, minus the amount of non-bonding, which is 0, minus the amount of bonding electrons, and that's 8 divided by 2, which equals 0 at the end. And then for sulfur, it has 6 valence electrons, minus the amount of non-bonding electrons, and that's going to be 1, 2, 3, 4, and that's going to be minus the amount of bonding, 4 divided by 2, and then you're going to get 0. Alright, as soon as you figure out how to do the first one, it's going to be a lot easier to do the rest. So, oxygen is going to have 6 valence electrons, minus 6 non-bonding, and then minus 1 bonding electron. That's going to equal -1. Carbon is going to be the same thing every time. 4 valence electrons, minus 0 non-bonding electrons, and then minus 4 bonding electrons. Like last time, is going to equal 0. Alright, so for sulfur, we're going to have 6 valence electrons, minus 2 non-bonding electrons, minus 3 bonding, and we're going to get 1. Alright, now for oxygen, you're going to have 6 valence electrons, minus 2 non-bonding electrons, and then minus 3 bonding, and you're going to have 1. Carbon's going to be the same every time, and then sulfur is going to have 6 valence electrons, minus 6 non-bonding, and then minus 1 is going to equal -1. Now we have to look at the numbers that we've received, and it's pretty easy because we got one with all zeros, and that's the first one, and this OCS molecule is the most likely.